Hello everyone. In this video, I will demonstrate how to build a PLS-SEM model using SmartPLS software. This is the model we're going to consider. Model has already been described in detail in my earlier video. Viewers are encouraged to look at my other video before coming to this one. Basically, this is satisfaction, commitment, and retention model. More satisfaction leads to more commitment, which in turn will lead to more retention. Likewise, higher satisfaction might lead to more retention of the employees in the organization. And they are all measured using 5-point Likert scale data, um, with higher scores denoting higher level of agreement with the statement. And for retention, we're using 1 as very unlikely to 5 very likely, and henceforth. So we also discussed in my last video the sample size, the missing values and outliers and normality issues. So we want to continue forward. We're going to discuss some concepts about PLS-SEM modeling here. The first thing is the constructs. So what are constructs and how they are different than other variables? So constructs are sort of latent variable. They are used to capture abstract notions, something that are not directly observable. So the variables could be of either of the two types. One is directly observable, the other one is directly the other one is not unobservable, to put it in that fashion. So what are observable variables? Observable variables are something like your age, or years of experience that you have, or the income. So all this could be directly recorded, and we don't need to worry about sort of measuring them. They are what they are, and we can record them directly. But there are some concepts like satisfaction or commitment or retention. So for example, satisfaction cannot be directly observed. Okay, so what we need to do is we need to develop the measures that's going to help us measure these concepts correctly, called satisfaction. And satisfaction becomes a construct or an observable variable, and for which we need to develop the measures, which are in the form of indicators or items or questions in your survey. So that's a brief discussion about the construct. The other thing we need to worry about is what's the difference between reflective and formative measures. So for example, if you see this latent variable one, it's a reflective measure, reflective construct. It has 3 items. So we're measuring this construct, abstract notion here, or latent variable, using 3 items, which are the indicators, and could also be said like they are the questions in your surveys. So they're the reflection, so that's why the arrows are pointing outwards. Simply means that we are trying to measure this latent structure, or latent variable, using 3 items. These items are highly correlated to each other. They are interchangeable as such. So you're gonna see sort of high collinearity between them, because they're all trying to measure the same thing. And so basically they are the reflection of the of a construct as such. So that's why they are called reflective. Again, they're going to be interchangeable to a certain extent. You expect high collinearity between them. But there is another way we can form model the latent variable. Here the latent variable is demonstrated as a formative measurement model. So here we are using 3 items here, which are forming the construct here. So basically these are parts, in combining 3 parts going to give you a whole. You can think it up in that fashion. And since they are formative, they are not supposed to be collinear to each other, so there will be very low collinearity between them, and that's what you want. And they are not interchangeable. They are all separate items. Again, the focus here is not to go into the details of formative and reflective measures. Viewers are encouraged to look into other sources to know more about them. The focus here is more on building PLS-SEM modeling here. Now, other thing is, PLS-SEM method standardizes both the raw score of the indicators and the latent variable scores. So as a result, all loadings and weights as well as path coefficients fall between the range of -1 and +1. So scores farther from 0 indicates strong relationship. So all the path coefficients are standardized, weights, loadings, everything are standardized, and they sort of range between -1 to +1. So if the farther away from the 0, that means stronger relationship. That's something we have to keep in mind. When you build the PLS-SEM model, you have to assess the model in two different ways. One is you have to first assess the measurement model, like all the measures that you're using to measure your construct. Are they reliable? Are they valid? That's the first thing you need to ask. And if after you sort of assess the measurement model, then you have to look into the structural model. Structural model simply means that, you know, the relationship between the constructs. So when it comes to the measurement model, basically you're evaluating the correlations between the construct scores and its indicators, or constructs and its indicator. And when you're evaluating the structural model, you're evaluating the correlations between various constructs in the path coefficient. So for example, here the focus is, when you're evaluating the measurement model, the focus is between the items and their construct here. So that's a loading or the weight we are interested in terms. In case of reflective measurement model, we are talking about the loading. In terms of formative measurement model, we're going to talk about the weights. And in terms of structural model, so this is like a structural model where we have many different latent variables, and we are sort of assessing the interrelationship between them using the path coefficient. So this is the third step as such. The first step is going to be, if you have reflective, we're going to assess the reflective measurement model, then formative measurement model, and then we're going to assess the overall structural model. So that's going to be the focus here. Okay, with that, I'm going to get started here. We already have the data in the form of CSV file, so I'm going to launch, let me launch it again. I'm going to close this one. Let's say I'm going to just open this one again, say SmartPLS. Okay, so once you open this one up, you can create a new project here. Let's say demo here, just to showcase you, and you can double click here to import the data. That's I have on my desktop folder. So it's in the form of CSV. That's very important. It can only take comma separated values. So if you're gonna say okay here, so it's gonna import all the data, the raw data we have. And right now we're saying that there are no missing values, but we know that from earlier video that missing values are indicated by -99. So I'm going to say that here, missing value marker as -99 here. So that's going to rerun the calculation here, and -99 will be indicated as a missing value. So as we know from the earlier video, we have a lot of missing values, almost 51,000. The data set size is 65,000. So even if you eliminate all the missing values, you still get a very decent sample size of 10,000 observation, which is very big by any standard. So once you do that, you have to start building the model. This is just for the demo purpose. I'm going to delete this one here. I already practiced that here, so I just wanted to showcase it to you. That's a data we just imported, very similar to this one. And I'm gonna start building my model here. Let's say I want to add one model here. Let's say create a new path model. Okay, so I'm gonna say let's say satisfaction retention model. So I'm just gonna give it a short okay, let's say satisfaction retention model 1. I'm going to call it 1. Let's delete the other one. We don't need this one. Now, so this is how the PLS software looks like. Okay, we're gonna click on that one. That's gonna take out that color palette. And now we have all indicators here. Okay, so let's say we want to focus on 3 constructs first. Let's say I'm gonna bring those satisfaction items. These are the items, reflective items. Again, we're not gonna get into why these are reflective and why they are formative. That all depends on the researcher's domain expertise and the theoretical backing of the model. But here they are reflective because we're going to see they are sort of highly correlated to each other, and they're going to give us higher loading in the model. So I'm going to rename this one. I'm going to call that as satisfaction. Okay, so I have another one. Let's say we have many indicators for commitment, but I'm going to use effective measures of commitment. Okay, so there are different measures, but here we're just going to focus on effective commitment. So we have all the indicators of effective commitment. We're going to bring it to the modeling window here. So that should be it here. So I'm going to drag this one and right click it. I'm gonna say align to the top here, and I'm gonna right click it and rename it to, let's say, commitment. I'm just gonna call it effective. So AFF, effective commitment. Okay, and then we're gonna have the third one, which is the retention, which is a single item scale. So I'm gonna call this here. So it's a single item scale. Right click it and set it to the right here. I'm going to say rename this one as retention. Okay, the single item scale here. So we're going to connect this small model using connect tool here, from here to here, from here to here, and it turns blue because now it is a valid model here. So now you have this very small model. We have 2 constructs here, satisfaction, effective commitment, and the third one, retention. Retention is a single item construct. It doesn't have a arrowhead here because when you have single item construct, it doesn't matter whether it's a reflective or formative, it's the same, because the weight is going to be, or the loading is going to be always 1. Which means that this item is perfectly measuring the retention, and rightly so, because we just have one measure here. But when it comes to satisfaction, it's a reflective measure construct, and effective commitment is also reflectively measured construct. And they have many indicators. Okay, and they will have loadings on this one. So as indicated earlier, let's go back to the model here. Okay, so first thing we're gonna talk about reflective measurement model. We have to assess that one, and when you assess that one, this should be since I use different nomenclature here, I'm gonna use VL1. Okay, that's our construct here. It has 3 items, so we have to sort of since there is a reflective measure, that means we expect high correlation between them. We have to assess the validity and the reliability. So we have to assess the convergent validity, we have to assess the internal consistent reliability, and we have to assess the discriminant validity. Now convergent validity simply means that how well these items are measuring this construct here. Okay, so higher the loading on the construct, the better they are. So on an average, we must make sure that all the loadings are greater than 0.7. Okay, so if you square 0.7, you get 0.49, which is the amount of variance extracted by this construct from all these indicators here. So all these indicators will have a lot of shared variances. Okay, and how much variances is being extracted out of all this indicator is what this extracted variance extracted measure indicates here. Okay, the more the better, but again, as I said, you can expect high correlation between these loadings, but how high is desirable? Well, as high as possible, but obviously not too high. If these correlations are greater than 0.9, then basically it means that you are simply duplicating the items over and over again, and they don't have any uniqueness left. So you want to have higher correlation, maybe more than 0.6, 0.7 among them, but you don't want to have very high correlation. So the loading of each item on the construct has to be greater than 0.7. That's the cutoff we're going to use here. So we're going to assess the convergent validity, we're going to assess the reliability in terms of composite reliability, which should be in the range of 0.6 to 0.9, and Cronbach alpha, which is also should be between 0.6 and 0.9. Now again, why should we let's put it other way. It should not be more than 0.9, because if it is more than 0.9, that means these items are basically same. Okay, so and that's something we need to worry about. So it has to be more than 0.6, but should not be more than 0.9 reliability. So that's something we have to keep in mind. And discriminant validity will be assessed using couple of the criteria. One is the most uh, what do you say, sort of recommended is STMT measure. Okay, and that has to be less than 0.9. Or when you run the bootstrapping confidence interval, that interval should not include 1. Okay, that's something we have to keep in mind. So again, PLS-SEM is a non-parametric test. That's why we run bootstrapping here to get our significant p-values. That's something you have to keep in mind. And if STMT is more than 0.9, that means constructs are not discriminating well. You're not going to have just one construct, right? You're going to have many constructs. Here, just one construct. So you're going to have this construct likewise here, right? So you want to make sure that all these constructs are sort of discriminating well among themselves. They are not the same, they are different. That's all it means. Okay, so we can assess that one as well. And is a note here, in case the construct is measured using single item, the relationship, that is the loading or the weight, loading in terms of reflective measurement model, weight in terms of formative measurement model, between the construct and each item is always 1. So because it's basically you're using just one item, so it's gonna be perfectly measuring the uh, the construct that you have. As such, it is meaningless to establish convergent validity or reliability, because it's just one item, right? There is no way you can establish the convergent validity or reliability. These are more applicable when you have more than one items. So, but we do establish the discriminant validity. We want to make sure that they discriminate well from other constructs in the model. Also, in such case, we cannot distinguish whether the construct is reflective or formative, which is exactly the reason you do not see the directed errors in the relationship in SmartPLS. So if you go to here, it's a single item scale, you don't see the arrows here. Like you see the arrows going away, means they're reflective. There are no arrows here. It doesn't matter whether this is considered as reflective or formative. That's something you have to keep in mind. So let's go ahead and run this model. We're gonna start PLS-SEM model here. This is the screen you're gonna see here. Path weighing criteria is what we're gonna use here to start with. Missing value indicator is very important. If you use the mean replacement, remember we have 51,000 observations that have missing values, and if you replace them with the mean, the data will become useless, because then there won't be any variation left. So we have to make sure that we delete all the missing values and do complete case analysis. And that's desirable in this case because maybe the survey was given out to only part of the employees in the organization. Okay, and even after deleting those 51,000 observation, we still have 10,000 observation left, which should be big enough for us to sort of have some insights in the model. So we're gonna do the case as deletion here. We're not gonna worry about weighing. We're not gonna worry about the data groups right now. Okay, We're gonna see that later on. But with this one, I'm gonna say start calculation. Okay, so let me close this one. We don't need this one. So this is our model here. Now what you see here, you see the loadings here. Okay, all the loadings here, and here the loading is going to be perfectly one. It doesn't matter whether you consider this as a loading or wait, because only single item here. So these are the path coefficients, telling you the sort of how strong the coefficient is, like a regression coefficient. It is a regression coefficient. So this is our dependent variable, this is independent variable, and that tells me the parameter estimate between the two variable. Likewise, you have path estimation here as well. Okay, and here you inner model is the structural model. This is our inner model, and outer model is the measurement model, how well we are measuring each construct. Okay, and then right now showing the R square value. So that means satisfaction, when it comes to satisfaction, the R square value for commitment is 0.35. That means satisfaction is explaining 35% of the variation in the commitment. Likewise, commitment and satisfaction are sort of explaining 36% of the variation in the retention. And that's pretty good. R square value greater than 0.25 is considered moderate effect, which is good here. That's something we have to keep in mind. Now, as I said, like we need to assess the measurement model here first. The measurement model, we need to assess the convergent validity. So let's focus on the convergent validity here. Now, as suggested, all the loading should be greater than 0.7. Here, if you see that this is low here, 0.5, not good, is 0.69, which is barely on the edge. So probably I'll just retain that. But this is something very low. I can remove this one. Again, this totally depends on the researcher, what they think about their model. To me, looks like I still have 4 other indicators to measure. So I'm gonna get rid of this one, right click it and delete this one here. Okay, and we have to rerun the model. Okay, so when you rerun the model, you still is 0.68. If you want, you can remove that. I'm just going to leave it in. Instead of the R squared, let's say I want to see average variance extracted values. So it's extracting 0.5, more than 0.5. All of them are more than 0.5. This is just going to be 1. Because just one item we are using here. So this just satisfy our conversion validity, which simply means that all these items are sort of valid when it comes to measuring the construct here, satisfaction. Like with all these commitment measures or items or indicators are valid when it comes to measuring the construct called commitment here, because they are loading highly on this one. Okay. So we have established here, we have to just do it for the 2-1, because this is single item. We're not going to do this one for when it comes to the conversion validity. And we also need to assess the, what do we call, reliability. Okay, so reliability is measured using 2 criterion. One is composite reliability, which is more recommended, and the other one is Cronbach alpha, which is sort of traditional way of judging the reliability of the construct. So again, we're not going to judge it here because it's a single item, but we're going to judge the reliability here and here. And for that, we have to go here, PLS algorithm run, and we have to look at the construct reliability and validity here. Okay, so you can see that Cronbach alpha here. This plot tells you that the minimum required is 0.7, and all the 3 constructs are sort of satisfying that construct, that cutoff value here of 0.7, which means they are highly reliable. Composite reliability is also very high, so probably better than the Cronbach alpha, and this is more reliable. So it tells me that, you know, all the constructs are reliably measured using their indicator, their respective indicators. And we already saw the average variance extracted. So in case of retention is going to be 1 because we just have one item, but others are doing pretty good as well. So we established the convergent validity and reliability here. The next thing is going to be the discriminant validity. And when it comes to discriminant validity, we need to click on this one. And there are many ways we can do that. One is called Fornell Larker criterion. It simply means that the correlation, let's say I would say the correlation, this this satisfaction where so this is the AVE, average variance extracted for satisfaction. If you take the square root of it, it tells you how much this construct is correlated with this item. Okay, so the idea here is the construct should correlate more with its respective items than compared to other constructs. Okay, because these items are what you're using to measure the construct in the first place, so they should correlate with the construct more than any other construct. So if you look at the here commitment, let's say effective commitment itself, like if you see if you take the square root of this one effective commitment, you're gonna get this value here 0.79, because this is the average variance extracted. Let's do that. So let's say I'm gonna do it here. Okay, say calculator, and let's say, okay, I need to see, I don't see the square root here. Maybe I don't have that thing here. Probably we can go to the Google and say calculator. Okay, so this is better. Let's say 0.636, 0.636, and if you take the square root of it, so I should have done it the other way. Let's say the square root of it. Okay, please clear everything. Square root of 0.636, right? Yeah, 0.797, right? And that's what we get here, 0.797, right? So that means the correlation between the construct and its indicators are is 0.797, but the correlation between the commitment and retention is 0.59, and the correlation between commitment and satisfaction is only 0.58, and so these are lesser than this one. So we are sort of saying that, okay, commitment is sort of discriminating well among other constructs, and likewise here as well, retention is discriminating well with others, because retention is just one item construct, but still we need to see whether it's discriminating well. And so it is satisfaction 0.746 is greater than this one. The other one is hetero trade mono trade, and this has to be less than 0.9, and all of them are less than 0.9 here. We always see between different construct, commitment to retention, commitment to satisfaction, and retention to satisfaction. So, and they're all less than 0.9, which is good. Okay, so we have sort of established what we call the discriminant validity, but we need to also see the bootstrapping confidence interval for STMT, and for that we need to run the bootstrap here. So I'm gonna do that here. So let's say I'm gonna click on this one, calculate this one, click on bootstrapping here, and let's do a smaller one for quick results. But in reality, you should be doing 5,000 runs, but I'm only doing 200 subsamples here. Complete bootstrapping will give me STMT confidence interval, so I need to choose that one. Bias corrected bootstrap and two tail and 0.05, they are the default. I'm going to leave it there. Path weighing scheme we are using here. Missing values, we are deleting them case wise, and I'm going to click on start calculation. It's going to take few seconds to run. Okay, so it's done it. So if you drop this one down here, you can see the bootstrapping result and the PLS algorithm result. Okay, so we are right now in the bootstrapping result here, and we had to click on STMT here. Okay, and STMT, this gives me the confidence interval for all the STMT measures. Okay, retention to commitment, satisfaction to commitment, and satisfaction to retention. And this confidence interval should not include one, and it does not. Okay, because if it is including one, that means, you know, the values are not reliable, and which could mean that, you know, basically they could be the same construct, retention and commitment, or satisfaction if it's all greater than 0.9, or if this confidence interval include one, or if these values are here greater than 9. If they are greater than 9, probably this might include 1 in the confidence interval, which means that they are not discriminating well among themselves, and you are not sort of satisfying the discriminant validity criterion. So here we have satisfied that discriminant validity. All STMT measures are less than 0.9. We also have looked at the Fornell Larker criterion as well. And you can also look at the cross-loading metrics, which is basically not needed after doing these two things. And we also looked at the bootstrapping confidence interval. We have sort of established here what we call measurement model. So our measurement model is reliable and valid. And we have assessed that using convergent validity, internal consistency, reliability, and discriminant validity. Now, after you do this one, the other thing is evaluating the model, how well the structural model is doing. So all these path coefficients. The good thing is that we have already run the model. We don't need to run it twice. We have to just interpret the results, and we're going to do that here. For example, for bootstrapping here, we can say that a gainer model give me path coefficients and p-values, right? So it's going to give me the path coefficient and p-values. P-values means all these five path coefficients are significant at 0.05 label, and they're very strong. So, and again, as you know, these are all standardized coefficients. Okay, so they're going to range anywhere between -1 to +1. And likewise, we can show the loadings and the p-values there for each item. So probably we're gonna just maintain some distance here. Okay, likewise we're gonna see some distance here so that they are better, right? Right, so they are all highly loaded and they're all significant. So when it comes to the structural model, all the path coefficients are significant. That means the relationship between satisfaction and commitment is significant, which means that higher satisfaction does lead to higher commitment, and this is also significant, which means that higher commitment also lead to higher retention. And this is significant, although it's a very small effect here, but we can say that, you know, higher satisfaction leads to higher retention as well. Okay, that's something you have to look at it, and you can get more details if you go to bootstrapping results here. For example, you can see the path coefficients, the same thing we looked at the diagram right now, and see how much effect is there. These are all direct effects. Okay, we are looking here at the direct effect. Now there are three types of effects. One is a direct effect. So for example, satisfaction on retention is a direct effect. And the other one is indirect effect. For example, indirect effect of satisfaction on retention is going to be the satisfaction on commitment and commitment on retention. So you can find the indirect effect here. Basically, if you multiply these two things, 0.583 and 0.63, the coefficient that you're going to get is the indirect effect. Okay, and the total effect is going to be indirect effect plus the direct effect. So if you, let's go back to our thing here, calculator here. So let's say I'm going to do here 0.83. Let's say point, let's say 0.583 times, let's say 0.63 0.563. So 0.328 is the indirect effect. Okay, so let's confirm that one. So I'm going to go here, bootstrapping result, see the indirect effect. And if you see the indirect effect here, let's say it's going to be better here, I guess. If you go to the PLS algorithm results, indirect effect here. So indirect effect of satisfaction and retention is 0.328, and that's what we find out here, right? Let's see here. Okay, it's hidden. A lot of windows here. It's here, this one. See, 0.328, and that's what we are getting here. Okay, that's something you have to keep in mind. That's how the indirect effects are calculated. And as I said, the total effect is going to be of satisfaction on retention is going to be 0.39. And how did you calculate that one? So what we have to do is, we have to, whatever indirect effect we found out, we have to add 0.062 there. So if you add plus 0.062 here, so you're gonna get a 0.390 here. Okay, so 0.039 is what we are getting here. 0.039, that's the total effect of satisfaction on retention, and total effect of commitment on retention is going to be the same because it's a direct effect. 0.563, 0.563, that's the only thing there you have there. And so, and there is no direct effect of okay, so we have a direct effect of we have total effect of satisfaction and retention because we have indirect effect and direct effect. So that's something you have to keep in mind here. And so you have to establish the p-values. The p-values are being established here. So the next thing you have to look at is the, when you're establishing the structural model, you have to sort of worry about few things here, which I have listed here. Let's say this one here. For the structural model, we have to, it's like very much like regression. Okay, first I did assess the path coefficients. We have seen the p-value is less than 0.05, and we can also see whether bootstrap confidence interval include 0 or not. So for that, let's go here. We have bootstrapping here and path coefficients, and we can do the confidence interval here. You can see the confidence interval here. They do not include 0. They are far away from the 0. Okay, which means that our p-values are significant. That's all it means. Which means that the coefficients are different than the 0. Okay, that's what it means. So here we assess this one. Let's assess the VIF, the collinearity. What we want to, since it's basically running bunch of linear regression here, ordinary least square regression here. So we need to make sure that there are no collinearity issues here, and we can look at those things here. Let's say collinearity statistics is VIF, and I don't think it's in here. Okay, it's not going to be in your bootstrap, but it's in here, collinearity statistics here. And we are more concerned about not the, we're not gonna look at the indicators VIF, the outer VIFs, because these are for constructs, right? And all our constructs are measured using reflective phenomenon. So when it comes to reflective phenomenon, we do expect high VIFs greater than 0.5. Here it's not there anyways, but this is not, we need to look at it right now unless we have formatively measured constructs. Okay, we have reflectively measured constructs. We need to look at the VIF among all the constructs as such. So for example, here if you're using commitment and satisfaction to predict retention, we don't want high sort of VIF between these two, or we don't want higher correlation between these two, or in other ways to put it is, we don't want higher shared variances among these two. Okay, and that is being measured by VIF. Okay, so when it comes to retention, we're gonna see the VIF between these two. Okay, and that's all we have. Okay, because otherwise all is gonna be, our commitment is being predicted by just one item here. Okay, so that should not be the problem here. So we go here. That's why we see here all the VIFs are less than retention. When it comes to retention, we are using commitment and satisfaction to predict retention. They are all less than 5, which is good. And commitment to satisfaction is going to be 1, because it just one construct we are using, satisfaction as a dependent variable to measure the commitment. This is going to be 1 here, but these are more important here. Okay, and they are less than 5. Less than 5 means you can calculate the tolerance statistics, which is going to be the cutoff value is 1/5, which is 0.20, which means that bare minimum, if it is less than 5, that means they are having more than 20% unique variance at least. That's the whole idea here. Okay, and which is very good. So here there are no multicollinearity issues between the constructs, and we do satisfy this criteria. We have seen that all the direct effect coefficients are significant, including the bootstrap, and we need to assess the R value here. So for the R value here, what we can do here is we can, for the outer model, we have to say that not here. Okay, we need to look at algorithm run. Okay, PLS algorithm run here, and outer model we have to, for the construct we have to say we are looking at the R square. Okay, so when you click the R square, you see those numbers are changed. There won't be any R square here because it's not a dependent variable. This is the dependent variable and this is the dependent variable. This dependent variable is being predicted by satisfaction and commitment, while commitment is being predicted by satisfaction alone. So it's like R square is 33% here, or 34% here, 0.339, and here it's 0.362, so 36% here, which means that my satisfaction and commitment together almost sort of explain 36% of variation in the retention, while my satisfaction alone sort of explain almost 34% of the variation in the commitment. And these are moderate effect. So if the R value is greater than 0.25, they're moderate. It shows moderating effect. If it is if it is greater than 0.75, it's a very high effect, and 0.5 is also the cutoff. Greater than 0.5 is also moderate effect. In fact, greater than 0.25, in between 0.25 to 5 is like a not so good effect as such, but still moderately good effect. So it's very rare to sort of get very high R square values when it comes to behavioral studies like this in marketing or human resources. So that's something you have to keep in mind. Now there is a flaw in the R square. R square is basically calculated using the same data, so it's also known as within the same data measurement, because we are using the same data. Not very reliable when you're doing the predictive modeling. So if you read the resources, they say that we have to use now out of sample data to find to sort of assess the predictive accuracy of the model. We're not going to do that here, but those who are interested, they can go here and run the PLS predict or do more research on that one, and that will give you an out of sample prediction accuracy. We're not going to focus there right now, but most of the research you do, R square is sort of more than enough to write it down. Okay, so we have established both the measurement model and the structural model, and we have moderately good R square values. We have significant coefficients, all the significant coefficients, and we can conclude that we are satisfying all the hypotheses here. So that's something you have to write it down. When you're gonna write it down, you will have to write down the measurement model evaluation, how you assess those measurements, whether they're valid and reliable or not. And after that, you have to sort of do the structural model. And structural model, you're going to assess the p-value, the direct path coefficient, indirect path coefficients, total effects, and you're going to assess the multicollinearity issues between the constructs, and you can assess the R-square value, which we have done it here. So this is how you do the simple modeling. We're going to start building or adding more constructs going forward, and I'm going to record another video going forward on those issues. With this one, I'm going to conclude my video here. Thank you very much for listening.